Mulishani bonse. Okay. Nebo kafundisha mlenga Fredrick. Kwena nangu chakuti bankansho kusambilisha physics, chemistry, ero na biology. Limonalitemu wako kusanga insamushi. So lero ndeti tafene mwine practice insamushi shobeto kuti calculus. So na ebati nanimo if ndeti ta practice na bamina bena kuti batemo kukonkamo. So that's why nara sharing a video afterward. So nkonkenmo. So we have a question. So this question is a calculus question. So we just look at certain principles that we will follow as we go on. Okay, so let me write this question. Okay, so question mkwai ni. So find the dy dx of y is equal to x, open bracket 3x minus 1, close to the power 2. So if you look at this function, it looks like x is multiplying what is inside the bracket. And when you are multiplying, the answer that you get, we call it a product. So we are going to use product rule to solve this calculus equation, or to rather to differentiate this one. So it says this rule, product rule says, it says that if you have an equation or a function which is like maybe u or v, others can use other letters. These are just letters, but the concept is the same. Or others you see they use fg. Okay, so it says that where u and v are functions, it can be f and g are functions, then a function of x, then the dy dx was that we are going to keep u and differentiate what? Differentiate v. Okay, if you are using f, meaning you keep f and differentiate what? G. So we're gonna have x there. Then what do? You add. Then you keep v, differentiate u. Okay, over dx. If you are having fg, you keep g and differentiate f. These are just the same thing. In case these are just letters, but the concept is the same. So I'll keep on the first one, I'll keep f, differentiate what? Differentiate g over dx. Then plus I'll keep g and differentiate what? F over that. Just like that. So this you can go in your own way, but the same concept. So now in the case of these question which we have that function, so our u, okay, let me just get it and bring it right here, okay, all right. So our u, I'll use letters u and v. Our u is that and our v is that. So we'll say let u be x and v be 3x minus 1 raised to the power 2. Okay, so the next step is that you differentiate these. You differentiate because now we have two functions, so you differentiate each one of them. So the derivative of u, the derivative of u respect to x, okay, is that x minus 1, okay. So this gives us what? This will give me 1, okay. Then we go to the second function. Now I want you to pay attention to this function and look at it. It has a power outside here, if you check. So when you have a power, then chain rule comes in. So chain rule says that if you have, it says that if you have a function like a u and it has a power there, and where u is a function, where u is a function, it's a function of x, and the a prime and u are constants, their derivative is found with this formula: dy dx gonna be dy, okay, du multiplied by du dx. That's how you, and that's a formula for chain rule. Now, so let's differentiate this function which we have now. So let me copy it and paste it somewhere. Okay. All right. So we differentiate this one, we'll bring it right here. Okay. So the formula is that we'll say, we'll divide the two. So I would say we'll let u be, so let u be what is inside here. Okay, so we'll pick what is inside. Okay, so our u gonna be 3x minus 1, okay, minus 1. Then our y is going to be u to the power 2. Okay, so now we are good to go ahead. So we are going to differentiate these. Okay, so du dx with respect to x, it's gonna be 3. Okay, we don't differentiate 1 because it's a constant, it's a number. Then the dy then respect to u gonna be 2 u and 2 minus 1, it will be just like that. So it will remain like that. So now we've done this. So we'll now apply what? Chain rule to finish now this one. So chain rule is telling us dy du times du dx. So we'll replace now what we have. So dy du, it's 2. Okay, but remember, u is what? U is this number or this function. So we'll replace, we'll substitute. So where there is u, you put 3x minus 1, okay, times, so times dy du. So what is our du dx? So our du dx is 3. So it will be 3 like that. All right. So now we can go ahead and expand this one. So today we can deal with 3 times 2. We are going to have 6 x minus 1, just like that. Then we multiply 6 times 3, we're gonna have 18x. So 18x. 6 times 1, we're gonna have 6 here. So this is our dv dx. So now we are good to go. So we'll get this question and factor it inside the product rule. So now we begin. So we'll use this formula, which is right here. Okay. So all right. So what is our u? What is our u? Okay. So u is x. So we'll get our x right here. Okay, let me write just below here so that I conserve the space. Okay. So I'll put x where there is u, x, then dv dx. What am I going to do? I'm going to replace this there. So dv dx, it is 18x minus 6. Okay, close bracket, then plus, what is v? So our v from this equation is what? Is that. Okay, so I'll simply put out these things inside there the way it is. So v is 3x minus 1 power 2 times, then what is my du dx? So my du dx is 1. Okay, so I've just picked this, which is here. That's my du dx. So then figure in putting it inside. So if we simplify this one, it's gonna be 1 times this, the order of things. So we are going to have the equation looking like this: x 1 2, okay, power 2, then plus it's gonna be x, then 18x minus 6, then close. And this is our dy dx of this function. Okay, so let's do another example. Okay, in case you missed it in the first one, you can also follow in the second one. Okay, so we have this function 4x squared, then we have this x minus 2. Okay, this is product rule because we have two things trying to multiply itself. So we'll let u be 4x squared, and our v, we'll let it be what? We'll let it be this. Okay, so are you following? So I hope you are following as well. So okay, so what do? We differentiate its function. So we are going to start with u. So let's differentiate u. So du with respect to x, it's gonna be, so 4 times 2, okay, then x power 2 minus 1, okay, so this gives us 8. Then 8 times x, that's definitely we're gonna have something like this here. So we are done with the first function. Then we go to the next one. So if you look at this function, we have v is equal to x is equal to square of x minus 2. So what do we do here? We know that the square means this. We know that it means 1 over 2. Okay, so 1 over 2. So this means would be written it will be written as x minus 2 in bracket to the power 2. Okay, if you are this type of question, you first remove the square, and by writing it in that form. So now what are we having now? It has taken us back to what? To chain rule. Okay, and we know how to deal with chain rule. So so from here I'll use any letters, of course, okay, but I'm used to u and v, so there's no harm. So I'll let u be x minus 2. Okay, that's what I'll do. Then I'll let y be what? Will be u to the power 1 over 2. Okay, so now we are good to go. Let's now differentiate this. So du with respect to x, okay, it's gonna be definitely it's gonna give me 1 here. We are not differentiating 2 there. Okay, so 1 here. Then the rest, this side, gonna be dy respect to u, it's gonna be it's gonna be, okay, so it's going to be that the half, okay, then u, okay, to the power half minus 1. So now this, it's gonna be written as half is equal to u, so half minus 1 definitely to give you negative 1 over 2. So this is gonna be, let me just write it properly so that it's not confusing. Okay, move it somewhere here. Okay, so this is what? This is my dy du. Okay, so now remember, we're now going to use our formula under chain rule. So chain rule formula, we know that we have to multiply du dx, okay, with dy du. All right, so what are we gonna do now? So du dx, from this my du dx is 1, so I'll put 1 right here, times what? Times dy du. So it's gonna be half. Okay, now wait a minute, what is u? So our u is x minus 2. So I'll replace that where there is u. So x minus 2. Okay, then power negative half. All right, so let's see. Let's play with the some math here. So 1 times everything, definitely it will give us just this. Okay, it will just give us the same expression. All right, so now this is my dv, this is my, remember, product rule. So this is my dv dx. Okay, so that's our product. So my dv dx. So I'll keep it now. All right, so now we are good. So I'll lift this and put it in the equation. Okay, so therefore it will be v differentiate what? Differentiate u over dx. Okay, then plus I keep u differentiate dv du. Okay, all right, so we'll replace what is my v from this. So my v, remember, my v is this equation which is here, just here. It doesn't matter whether you swap them or what. You can, for example, you can say v du dx or u dv du. So anything, it works out at this point. So my v is this. Okay, that's my v. Then remember, I'm multiplying with my what? My du dx. My du dx is this one. So I'll put 8 there, multiply by 8x. Then plus, okay, then what is my u? So my u is 4x squared. So u 4x squared. Then what is my dv du? So my dv dx is this. So I'm going to replace this there. Okay, let me just move this a little bit this side. Okay, so it is, okay, you write it the way it is, x, okay, we use that one, x minus 2, okay, just like that. Okay, so let's play around with the mathematics just right here. Okay, so 4 times half, definitely 4 times half, it is going to give you let me try to do like this so that to do these things to look neat. Okay, so 4 times that, it is definitely going to give you 2x squared. Okay, then you are remaining with what? You remain with x minus 2. Okay, to the power negative half. Okay, then here you just rearrange these things. So it be 8x. Okay, x minus 2, and this is our final answer, just like that.